Hi guys, so today we're going to do an introduction to GCF, which, as you probably know, stands for greatest common factor. We'll go through what GCF is, the process that you should take when you're looking for the GCF of a polynomial, and we'll do a few examples. At the end, I'll leave some examples for you guys to try on your own. So let's get our brains warmed up to the idea of GCF so that when we jump in, you guys will be ready. So let's start by breaking it down. What does the word greatest mean? Click your answer. That's right. The word greatest, of course, means biggest. Okay, so here is our second warm-up question. What does the word common mean? Take a minute and choose your answer. Right. Common means shared by all. For example, if I asked you, what does everyone taking this class have in common? We could say that they're all learning intermediate algebra. Okay, our third and last warm-up question. What does the word factor mean? Take a minute and pick your answer. Right. Factor means numbers that are being multiplied together to produce a product. For example, if I asked you to give me 2 factors of 18, you could say 3 and 6. Because when we multiply factor by factor, 3 times 6, we get the product 18. All right, why did I ask you those questions? Because I really wanted you to get your brains warmed up and ready and thinking about what a greatest common factor is. It's the biggest factor shared by all, right? Greatest means biggest. Common means shared by all. Factor means when you multiply factors together, you reach a product. So GCF, of course, means greatest common factor or the biggest factor shared by every term. Now we're going to be finding the GCF of these polynomials that we've been talking about, right? We have these polynomials that can have many terms in them. They could have 1 term, 2 terms, 3 terms, okay? Each term is going to have a coefficient and a variable. And so now it's going to be our job to find the greatest common factor shared by these polynomials. So when you're doing that, you want to ask yourself 2 questions. The first of which is, what do the coefficients have in common? And I'm hoping that by now you guys feel pretty comfortable with that vocabulary word. And if you don't, you need to go back to the video where I gave you an introduction to polynomials and make sure that you rewatch it and understand that vocabulary word. So you're going to ask yourself, what do the coefficients, the numbers, have in common? And the second question you're going to ask yourself is, what do the variables have in common? And when you do that, you're going to take the variable with the lowest degree for your GCF. Again, if you're not comfortable with that vocabulary word variable, you need to go back and watch our Introduction to Polynomials video. So you're looking to find what the coefficients have in common and what the variables have in common. Once you have found your GCF for your polynomial, you're going to factor it out by dividing. And you need to remember to include your GCF in your final factorization. So once you looked at a polynomial, you found the GCF, you factored it out, you go to write your final answer of this polynomial factored, you have to remember to include your GCF in your final factorization. It is something that so many students forget. I even do it from time to time because you do all this work to factor out that GCF, you forget to go back in and put the GCF. So you'll see what I mean as we go through examples. I have 2 examples here for you and then a slide at the end where you can practice on your own. So let's walk through these steps one by one through these examples so you can actually see what the process is, because that will make it much easier to understand. So let's look at our first example. Here we have a polynomial. The polynomial is 12x to the 5th plus 18x cubed plus 24x squared. And the directions might say something like, find the GCF and factor it out. Okay? So the first thing we want to do is, of course, ask ourselves, what do the coefficients have in common? And as you'll see, I highlighted the coefficients in red to try and make it really clear. So in our first term, the coefficient is 12, and in the second term, our coefficient is 18, and in the third term, our coefficient is 24. So we have the coefficients 12, 18, and 24, and we want to ask ourselves, what do they have in common? So we're basically asking, what do they all share a factor of? So take a minute, think about the factors of 12, 18, and 24, and think about which one of those factors they have in common. That's right, they all share a factor of 6. We can evenly divide 12, 18, and 24 by 6. And there are other numbers that we could divide 12, 18, and 24 by, but we want the greatest of those, right? We can divide 12, 18, and 24 by 2, but there's a bigger number that we can divide these numbers by. 6, right? That's the biggest. In fact, we could have divided them by 3, right? 3 times 4 is 12, 3 times 6 is 18, and of course 3 times 8 is 24. But 2 and 3 are not the biggest factors that they all share. We want the biggest factor they all share, and the biggest factor that 12, 18, and 24 share is 6. So that is what we want to pull out for our GCF. But we're not done yet, because now we have to ask ourselves, what do the variables have in common? And when we do this step, we can always take the lowest degree, and I'll tell you why in a minute. But first, let's talk about the variables in each of our terms. So our first term, the variable is x to the 5th, right? Our second is x cubed, and our third is x squared. So the variable with the lowest degree is, of course, x squared. So before we go on, I just want to tell you why we take the variable with the lowest degree. Let's think about it for a second. So when we're thinking about GCF, we're thinking about the greatest thing that these terms have in common, right? The greatest factor that these terms have in common. So in our first term, we have x to the 5th. And if you remember from one of our previous videos, I explained that the degree just means how many copies we're multiplying together. So here we're multiplying 5 copies of x. 1, 2, 3, 4, 5. In our second term, we have x cubed, which means we're multiplying 3 copies of x. 1, 2, 3. And in our last term, we have x squared, which means we're multiplying 2 copies of x. 1, 2. We want the greatest amount that they have in common, right? It sounds kind of counterintuitive to say take the lowest degree when we want the greatest that they have in common. But the key here is to really think about the fact that they have to have them in common, okay? Which means that they all have to share that amount. So if I was thinking greatest common factor, oh, well, the biggest degree I see here is x to the 5th. That would mean they'd all have to have 5 x's, you guys. But do they all have 5 x's? Well, x to the 5th has 5 of them, but x cubed only has 3, and x squared only has 2. So do they all have 5 x's? Well, no. Okay, well then x cubed. That would mean they'd all have to have 3 x's in common. Well, the first term has 3 x's, the second term has 3 x's, but the last term is missing an x. We only have 2 here. So let's try x squared then. That means that every term would have to have at least 2 x's, right? Well, the first term has 2 x's, the second term has 2 x's, and the third term has 2 x's. So the most x's that all of these terms have in common is 2. They all at least share 2. And this rule will always work. So when you are thinking about the GCF, the variable, the degree to which your variable should be raised to for your GCF, you always want to take the variable with the lowest degree, because all of those terms will have at least that many x's, or at least that many y's, whatever your variable is. It will have at least that many of your variable, each of your terms. So the rule of thumb is to always take the variable with the lowest degree, because they'll all share at least this many, okay? That is the greatest amount that they will all have in common. So now we have our coefficient for our GCF and we have our variable for our GCF. Let's put it together and that will make our GCF 6x squared, okay? So we've now found our GCF. Our GCF is 6x squared. Well, now we have to go back to our polynomial, our original polynomial, and factor it out. So let's do that, okay? Let's factor the GCF out by dividing. So here's our original polynomial. I'm just going to divide each term by that GCF. So I'm going to divide my 12x to the fifth by 6x squared. I'm going to divide my 18x cubed by 6x squared. And I'm going to divide my 24x cubed by 6x squared. I don't know why I accidentally threw in that plus sign. Okay, that's what you're doing. When you're pulling a GCF out, you guys, it's a factor you're pulling out. So you have to divide it out. All right, we're doing that inverse operation, right? So 12 divided by 6 will give us, what? 2. And we know how to do polynomial division, right? We just learned this in our first week of our course. So when we divide variables, we simply subtract the degrees. So x to the fifth divided by x squared, well, what's 5 minus 2? 3, so that gives us x cubed. So now let's move on to our next term here, 18x cubed divided by 6x squared. Start with the coefficients, 18 divided by 6 is 3, and x cubed divided by x squared is just x, right? Because 3 minus 2 is 1, so x to the first power is just x, all right? We don't typically write that 1. And then, of course, lastly, 24x squared plus 6x, divided by 6x squared. Divide the coefficients first. 24 divided by 6 is 4. And x squared divided by x squared, well, that's just going to cancel. All right? So that leaves us with this. All right, so when we pulled our GCF out, when we factored it out of our original polynomial, we were left with 2x cubed plus 3x plus 4. And this is when I get to that last step that I said, okay, this is what most students forget. When you write your final factored form, you have to remember to include your GCF. So the final factored form with the GCF included would be 6x squared times 2x cubed plus 3x plus 4, okay? Here's our GCF. We can't forget to include that. And here's what we got when we pulled our GCF out. What we're doing here is factoring, you guys. And when you factor, you need to make sure you have a factor times a factor. So you cannot forget to include that GCF. So now let's look at another example when we have an extra variable included and a negative sign. Here's our second example, and in our second example, the polynomial that we're starting with is negative 20 a to the 8th, b to the 4th, minus 30 a to the 6th, b squared, plus 40 a to the 4th, b to the 7th. And the first thing that I want you guys to notice is we now have a second variable. Okay, in our first example, we were only dealing with one variable, x. Well, now we have two variables. We have the a variable and we have the b variable. And so when we pull out our GCF and we get to that step where we're figuring out what our variables have in common, we now have to consider what all of our a's have in common and what all of our b's have in common. So you'll see that in a minute. The next thing I want you to notice is that our first coefficient here has a negative sign, and that's going to be important when we pull out our GCF. So let's get started. So again, the directions here might say find the GCF, pull it out, find the GCF factor. Okay, just some examples of what those directions might ask you to be doing. So the first thing we're going to do is ask ourselves, what do the coefficients have in common? Okay, and our coefficients here are negative 20, 30, and 40. All right, and actually I should say negative 30 and 40. What's the biggest thing that they all share a factor of? What's the greatest thing they have in common, okay? So take a minute and ask yourselves, what do negative 20, negative 30, and 40 all have a factor of? The biggest factor that they share is negative 10. And here's the thing about GCF, you guys. When you are looking for GCF, if your leading coefficient, that means your first coefficient, includes a negative, you always pull the negative out, okay? If this had been positive 20, let's say that negative had gone away, okay? And this had said 20, a to the 8th, b to the 4th. Even if my other terms had a negative sign in them, okay, I wouldn't pull the negative out from my GCF. I just wouldn't do it. I always pull a negative out from my GCF when my leading term, the first term in my polynomial, has a negative coefficient, okay? So because my first term of my polynomial, my leading coefficient, has a negative, then I'm going to pull that negative out as part of my GCF, okay? So you always pull a negative out in your GCF if your leading coefficient has a negative sign. That is a rule of thumb. All right, so I found the coefficient for my GCF. It's negative 10. So now I need to ask myself, what do the A variables and the B variables have in common? So I'm remembering I always take the lowest degree. Let's look at my A variables. I have A to the 8th, A to the 6th, A to the 4th. Okay, my B variables are B to the 4th, B squared, and B to the 7th. So my variables with the lowest degree, take a minute and think about it. So for my A variables, that'd be A to the 4th. And for my B variables, the lowest degree here is, of course, 2. So that would be B squared. So I'm pulling out A to the 4th for my GCF and B squared for my GCF. Okay? So now I have my coefficient. I, of course, have my variable terms for my GCF. My GCF is then negative 10 A to the 4th B squared. My next step is to factor it out. And that's simply by dividing. So I'm going to take each of these terms. This is just my original polynomial. All I did was rewrite it, but I just took the colors out. All right, so negative 20 A to the 8th B to the 4th. I'm going to divide by negative 10 A to the 4th B squared. I'm just dividing each term by my GCF. Now negative 30 A to the 6th B squared. My second term I'm going to divide by negative 10 A to the 4th B squared, and of course my last term I'm now dividing by negative 10 A to the 4th B squared. Okay, I'm just factoring my GCF out. All that means is divide each term by the GCF. When I divide negative 20 by negative 10, I of course get 2. Those negative signs cancel. A to the 8th divided by A to the 4th. Well, I'm just subtracting the degrees, so it gives me A to the 4th, right? Because 8 minus 4 is 4, so that leaves me with A to the 4th. And now, of course, B to the 4th divided by B squared. Again, I'm just subtracting those degrees. 4 minus 2 is 2, okay? So now I go to my next term. My next term is negative 30 A to the 6th B squared divided by negative 10 A to the 4th B squared. So negative 30 divided by negative 10, that's going to give me a positive 3. Right? All my negatives are canceling. 30 divided by 10 is 3. A to the 6th divided by A to the 4th, that leaves me with A squared. B squared divided by A squared, well, that's just going to cancel. So I'm going to have no B term there. And then, of course, in my last term, when I do the polynomial division here, I am left with 40 divided by negative 10, which gives me a negative 4. A positive divided by a negative leaves you with a negative. A to the 4th divided by A to the 4th, that's going to cancel out. And B to the 7th divided by B squared leaves me with B to the 5th. Okay? So now I need to write this in the final factored form with the GCF included, okay? Which gives me negative 10 A to the 4th B squared, that's just simply my GCF, times quantity 2A to the 4th B squared plus 3A squared minus 4B to the 5th, which is what I got when I pulled my GCF out. Because remember, we're writing a factorization here, which means we need a factor times a factor. And our GCF is one of those factors. This is my second factor, okay? So don't forget to include your GCF in the final factor form. All right, so that is how you find the GCF and how you factor it out of your polynomials. I would like you guys to now try a few of these on your own. So when you get to the next slide, you're going to see a few examples. So here are a few examples that you can try on your own. If you feel like you've got it, great, just jump right in. If you feel like you need a little guidance with this, my recommendation is to write each of these on a separate page in your notebook. Go back to the beginning of this video, to each of the examples, and as I go through each step on the example, you do that for your problem, for each of these particular problems. Okay, so as you watch the video, pause it and do whatever step I just did in the video, do for the problem that you're working on. Then unpause it. Do the next step, watch it on the video, then do it for your problem. Pause it. Then the next step, watch it on the video, do it for your problem, and work through it that way, okay? And you'll start to get really comfortable and in a rhythm with this. If you really can't get it after you've tried it, watch the video again, tried it again. Then go into Blackboard and under our discussions forum with our questions discussions forum, you can post a question there and I will get back to you. Okay, so best of luck. Have fun. I know you can do it. And I know you'll get in a rhythm with this. The more you practice, the better you'll get, you guys.